Hello there again. Um, Today we're working on a section 8.5, um, page 657. But before I start, I have to go to announcements. Well, I have to do some announcements before that. So remember tomorrow. Well, not tomorrow. Thursday at 2 o'clock, from 2 to 3. I'm in the forum. If you have any questions there, that's where you can ask them. But I haven't seen you work on your assignments though, so I don't know how much good that's gonna do. But if you do have any questions, I'm gonna be there from 2 to 3, and I might be in a meeting, but I'm gonna keep an eye on that. Yeah, I didn't think about that. Anyway, what else? Let me see. I had another announcement, but I'm drawing a blank right now. So if I remember, I'll let you know. I'll email you. Anyway, section 8.5. Section 8.5 is a really simple section. It's all about using formulas. What this means is basically what you've learned all these sections, all these previous sections about solving for the missing variable. The only difference is now you're working with several variables. Okay, so in other words, instead of having an equation, you have a formula, an equation that is a formula which has different variables. Yeah, it's composed of different variables instead of composed of constant terms, coefficients, like the previous examples in previous sections. So anyway, the only difference now is that formulas are pretty much standard equations, like for use in different applications. The book. Oh yeah, I remember. So if you can keep up with me here, just go to your multimedia library and find this section, okay, in there, in your book, in your ebook, okay. That's what I was forgetting. Anyway, the book says suggests things where formulas can be used. Like for example, where was it? Hydraulic. Ponzi schemes among other things can be used in Ponzi schemes, gravitation, screen products, Doug's age, hydraulic fracturing, intelligence, all very random things, because literally you can use math, algebra, formulas, anywhere in everyday life. Yeah. Literally, quite literally. So what we're gonna learn is we're gonna be learn how to solve for the missing variable. In this case, though, remember that we don't have any constant terms, or coefficients, or if we do have like terms, we use the same rules that we've been using to put together like terms and to solve for the missing variable. Okay, so it's nothing. It's nothing really new, except for we're going to be working with variables. So what does that entail? Well, remember that when we only were working with one variable, and sometimes we had more than one variable and then we had to combine like terms. Yeah. That's the only thing you're gonna have to watch out for here. The rest of the variables go on the other side. That's it. On the other side of the equation. So let's see what that looks like. And I'm gonna write it down because yeah, you need to be able to see what's going on. So for example, if I'm solving for W, I believe it is, yeah, W, and I have this formula. Okay, so in this case, we don't call it equation, we call it formula, even though it is an equation. And I'm solving for W. Okay, well, what does that entail? Well, it calls for isolating the variable on one side, right? And I know I'm solving for Y. I'm not W, yeah. So I know I need to move L. So just like we did with coefficients before, except for this is still coefficient of W, but it's not constant. It's not a number. It's a variable. But still, the rules still apply here. And so we need to use the multiplication property of equality. We divide both sides by L. Oh, L, that's not a T, that's L. And we'll end up with L divided by L, that's 1. 1 times W, that's W on that side. This over here stays the same because these two are not like variables, right? Therefore, you cannot combine them together. You can only write them together, all right? That's the only difference. And you're done. If I want, I could write W on the left side instead of the right, and write this on the right side, right? See, that's easy. So notice that I didn't have to move this to the left, the variable that we were solving for. I didn't have to move to the left till the end. Sometimes it's useful, sometimes it's not. Yeah. So it comes to practice. You know when to do that and when not to do that. In this case, I knew that it was good. It's okay to leave it here, leave it on this side. All right, but that's because I had a lot of practice with this. Anyway, let's move on to the next one. And in this case, I'm not gonna practice a checkpoint, one of those checkpoints problems, since all these rules you already know, essentially. If I come up with across a new rule, I'll let you know, and I think I will at the end there. But it's not gonna be. Well, it is. It's gonna be something different, but related to what you already know. Anyway, this problem calls to solve for W, right? So I'm just gonna write it here. 2L plus 2W equals P. Okay. So notice how we have the W on the left side there. So I'm gonna isolate it here since it's already on the left side. But notice that this looks like pretty much like an equation that all the equations we've been working with. Sometimes you have equations with more than one term, right? See, this is one term right here. This is another term. And so that's once you practice a lot, you're gonna see that this pattern here, that you either have just one term, like on the left side there, or two or more, right? And that pattern is going to repeat again and again, even if you have divisions here. But remember that you can separate the terms just by looking at the positive and negative signs, okay? And so in this case, there's a positive sign there. That means this is one term, this is another term. Okay, so the next step is going to be, okay, since this was the first step to determine where your terms ended and where they began. Then the second step would be to move whole terms. Remember, that's exactly what we've been doing. Move whole terms to the other side. Okay, move whole terms to the other side. It doesn't make a difference how, if you have 50 or 60 terms over here, move all of those terms over to the side. If you cannot combine them with the W, if you don't have any like terms, move them all to the other side. That's the second step. Okay. So in this case, I don't have like terms here, so I can combine these two. Therefore, I need to move 2L to the other side by using the addition principle. See, the addition principle still, property still applies here. Okay, I'm subtracting both sides by 2L, and that's how I'm gonna move that 2L to the other side. Okay, the whole term. Okay, remember, whole terms, move whole terms together, and that's gonna make it even faster. That's the second step. Okay, so I'm just gonna write this 2 minus 2L. Okay, just to have it in one line there, and you can do that too. It'll save some space because we're gonna be working underneath that, right? All right. So in this case, I know I need to solve for W, so I need to move the coefficient of that over to that side by using the multiplication property, which calls for division. So remember to move the coefficients, including the sign. Okay, including the sign, and in that way you don't have to do two steps. You can only do one, like we did here. 2 divided by 2 is just 1. 1 times W is W. And here I have, and I'm just gonna rewrite everything here so you can see exactly where we are. I have P minus 2L divided by 2. However, this is not simplified enough. You need to simplify as much as you can. Okay. So in this case, remember that this, since this is a fraction, this is the denominator. Therefore, let me rewrite it so you can see it. Therefore, it is a common denominator. 2 is the common denominator. 2 P into negative 2L. Okay. This means this. Okay. So watch out for that, because here I can divide that. 2 divided by 2 is L. Well, 1 times L, which is L. I'm gonna rewrite P over 2 minus L. See how that got rid of the 2 over 2? And this is the simplified version of it. And I believe this is what the software wants, Pearson. All right. And you're done. Well, in this case, they left this answer as this step right here. So I don't know. I might be wrong. The book may not want, or maybe we'll accept this answer too. But anyway, either of those two answers should do, and more than likely the software is going to take this answer. Okay. I didn't come across. I already practiced all the assignment problems, but I don't think I have anything that looks like this on there, because I already worked them out. So you don't even have to worry about that. Okay. All right, let's move on. Example 3. It is, here we're solving for P, and I'm just gonna rewrite. I'll rewrite the whole formula. Okay, So it's not well, it is an equation, but we call this formulas. All right, so here we need to solve for P, okay? And in this case, again, you need to identify all your terms, all your different terms. And then since we're solving for P, we need to try to solve for P. I'm just gonna leave it on that side. What do you want? I'm gonna have move the whole thing, that P, to the left side, so you can see what it looks like. In that way we practice. Let's go ahead and subtract both sides by PM. Okay, PM. That would look like this: negative PM plus T equals D, because that went away, essentially. All right, so now we're here. Now see how we have PM on P on the left side. That means we need to move the other term over to that side by subtracting. All right, and since this goes away, essentially we end up with negative PM equals D minus T. All right, and then from here I need to solve for P, so I'm gonna rewrite this M over on this side, and I just swap these two, which mean the same thing. It's just multiplication, and the whole thing is gonna be negative. So I didn't do anything except for move the M to this side and the P to this side. That's all I did. And then I'm going to rewrite this side. All right, and since I know that I'm solving for P, well, doesn't this look familiar now? Because I need to move the coefficient of P, which is M. Remember I told you to remember to move the whole coefficient, including the sign. Okay, so that's what we're doing here. That's the only reason I did this movement here. So just in case you didn't catch that. Okay, negative M divided by negative M is 1. 1 times P is P equals D minus T over negative M. Okay, now here we are not done because this is negative. Remember that we don't want negative values. Well, in this case, this M needs to be changed. Let me see. What am I saying? Yeah, this is gonna make everything negative. Well, how can I explain this? I'm gonna need to change signs here. But why? What did I mess it up? Subtract negative P over this side. Negative. Let me start negative. D minus T. Minus P and negative PM. Negative. Oh, here. I'm supposed to add. I'm supposed to add. So that's it. That's the answer. P equals D minus T over M. Okay, that's it. You're done. That's the answer. All right, and we're done. All right, let's move on. Let's continue practicing here. Yep. Let's practice one more time here before we learn the new concept there. Before we learn the new concept on this section. Yeah. So this, I'm just rewriting the formula. Remember, formula is t equals d plus, no, that's the same thing. My bad. It's down here. W over 2 minus 3h equals 53. And we're solving for w, okay? All right, so since it's the w is already on the left there, there's one term, this is another term. Because of this sign, I know I need to move that whole term over to that side. Remember the first step was to combine like terms or simplify, but in this case we don't have any like terms. We don't have any parentheses either, so we need to move this term over to this side by adding 3h to both sides, 3h, and then from here this goes away basically. That's 0. W over 2 plus 0 is just w over 2. Oh, I don't know why it does that. Oh, I might need a lamp or something because this is too bright. Okay, so let me see, where was I? And then 53 plus 3h. I'm just rewriting down on the outside. And then from here, I need to use the multiplication principle to multiply the whole side times 2. Therefore, I need to multiply the whole side times 2. Okay, that other side. 2 divided by 2 is 1. 1 times w is just w. And then here, 2 times 53 is 106. 6. Remember, with distributing here, you need to multiply times that term, okay? And then 2 times 3 is 6h. Okay. So even though, notice that even though these are not like terms, essentially, we can combine them together just by multiplying times the coefficients. All right. And then from here on, we're done. We are done. So let me check the answers, if we got it correctly. Yeah, that's the answer. That's the answer. So so we're done with that. And I believe that's as difficult as the assignment problems are gonna get for this 4 examples. Anyway, let's move on to the new concept that I wanted to introduce in this section. Okay, so this is going to be a bit, well, you probably learned this in high school, but probably don't remember it. But I'll explain to you again here. Okay, so we're still trying to solve for this case. In this case, we're going to be solving for p. That's what we're doing, okay? So I'm just rewriting a equals p plus p RT. All right. In this case, we're going to be solving for p. So I'm going to move this p over to that side, to the left side, by subtracting both sides, right? So because this is one term, this is the other term. Subtract p from both sides, you end up with a minus p equals p RT. P times r times t. Okay, and then from here we subtract a from both sides, and if you already know what's going to happen, you can fast forward, but I need to explain to you what's going on by trying to solve for p here. Okay, so this goes away, that's 0, so I end up with a negative p equals p RT minus a. minus a. And then from here, since we want a positive variable here, just change our sign, right? Or multiply times 1, the negative 1. Both sides, do it to both sides. If you multiply negative times a negative, that becomes a positive. Negative times a positive becomes a negative. BRT. Negative times a negative becomes a positive. Whatever. And now my P is by itself here, right? Well, the only problem is that this P appears twice, see? So this cannot be the answer. This cannot be the answer, because there's another P here. And remember that we need to combine like terms? Yeah, well, not like terms, but well, we do have to look, combine like terms. But in this case, these two terms are not like terms. See, because you have other variables in here. Now, if both of them were PRT plus PRT, then this would be like terms. These two would be like terms, and we could add them up, and you end up with 2 PRT. This is the only way these two terms can be like terms. These are not like terms, okay? So we run into a problem here. Since we couldn't do this, we couldn't combine these two P's together by doing this. See, going from here to here. Notice how we got rid of those two P's and convert them into one. Well, that's because these were like terms. In this case, these two are not like terms. So we run into a problem. And this is where the new concept comes in. So I'm gonna leave that up there so you can see it. I'm just gonna write here underneath this because I want to remind you about. No, I'll tell you what. I'm gonna put that away, and I'm gonna remind you about how you distribute. Let's see. Hold on. I'm trying to come up with the best scenario for this. No, let's do P. Remember when we have a parenthesis. When we have parenthesis, we come across a parenthesis that is composed of two terms, like a 1 plus RT, right? Remember how we and we did it just a few minutes ago. How we need to use the distributive property, right? We need to multiply this, well, in this case, a coefficient. Yeah, you can think of it as a coefficient of all of this, or a factor. I'm sorry, a factor of all of this. This P is a factor of this, all of this, and then we need to use the distributive property, multiply, essentially, P times this first term and P times that second term. Remember those were the rules. Okay, well, what happens when we multiply? And this is multiplication. This, using the distributive property, we are multiplying. That's what we're doing. That's multiplication, right? We're multiplying this times this times that. We're multiplying, right? Okay, so let's go ahead and multiply. P times 1 is P plus P times positive RT. It's just PRT. The only thing you can do is write them together, right? Okay, so there it is. And so you end up with P plus PRT RT, right? Since we multiplied this times this times this, we ended up with this. So now we're here, okay? Well, notice how that looks exactly the same as this right here, right? P plus RT and P plus RT, okay? And notice where it came from. It came from a multiplication, right? Came from multiplication. Okay, since I called this procedure, you're going from here to here, right? Going from this step to this step. I call it multiplication, right? And that's what we call it. Yeah, we call it multiplication. Well, what would happen if I go from here to this step, so backwards, essentially? What happens if I go from here to here? Because it essentially can be done, right? Since we went from here to here, why can't we go from here to here? Backwards, going the other way. Well, we can. It turns out that we can, and we have a name for that. It's called factoring, okay? And you need to learn this word. We're going to use it a lot here. Well, not here, but in algebra. But we're going to use it here in this problem. We may not use it in that many problems for the rest of this class, but if you can remember this name, factoring, you're going to be ahead once you take the second part of this of math, development of math. You're gonna use factoring a lot. So if you can learn it here, remember it, that would be awesome. So what is factoring? And here again, you can use your own words, because the book doesn't tell you exactly what factoring is. It's gonna tell you something like, well, it's essentially the reverse of multiplication. Yeah, that's exactly what it is. So let's say I was here, and I'm just gonna rewrite over here, so it's out of the picture there. In that way, you don't get misled right there. Okay, so if I'm here and I wanted to factor, what does that mean? Well, you could say factoring is the same thing as multiplying two values that will give me the original equation in return, right? Something like that. Since this is the original equation, expression, and if I multiply two factors, in this case, I'm going to multiply something times a parenthesis there. And I know it's going to be positive, because if I multiply something times something, it's going to... I can't. Why is it doing that? Okay, there it is. Okay, I was saying, I don't know where I missed you there. I don't know where I went blank there. But there you go. All right, so P, what was I? Okay, so I was saying that factoring is two factors that will multiply together, give you back your original expression, okay? So I know that this, I can count that as a factor. I need to multiply times something. In this case, it's going to be P, because I know that if I multiply P times something, it's going to should give me back this first term. And if I multiply P times this term, times this, it's going to give me back this term, okay? So in this case, if I multiply P times 1, that's going to give me back this P. So it's going to give me back this part of the equation, or the expression. If I multiply P times RT, that's going to give me back this portion here, okay? And that's it, you're done. I went from here to here, and that is called factoring, okay? It's called factoring. When do you use it? Well, when you have terms like this that are not like terms, but that have two different, two of the same variables in it. Okay, one variable in one variable in one term and the other variable on the second term. And in this case, you cannot combine them because these two are not like terms. You cannot. Well, that's what I said. Cannot combine them. And since you only need one variable to isolate and on whenever you're solving for that variable, this is what we need to do. We need to factor. Okay, so let me go back to my problem up here. Okay, so since we were here, right, that's my original problem right there, and I factor that right side, the right side of the equation. So I'm just going to rewrite a on this side, so you can see where we are now. Now we are at this step, and now let's write a over here too, so you can see where we came from. Okay, so that's what that was the original equation formula, and now we're here because we factored. Okay, now we're ready to solve for p because we only have one p now. See, since these two are factors, multiplication, that goes for division, right? Division of this factor. I'm just going to leave p on that side. So that's 1 plus rt. And I need to do it to both sides. That's 1 plus rt. Okay. This goes away. That's p on this side. Yeah, you end up with p on that side. And then here, just rewrite everything because you don't have any like terms and you can't combine them. So the answer is p equals a over 1 plus rt. And that should be the answer. Okay. And it is right now. All right. Let's practice one more problem. One more of those. The checkpoint problem there. So now I'm gonna go a little faster because now you know exactly what I'm doing. Okay, I'm just gonna rewrite it over here. Now I know why it's too bright. I don't know what that is. I don't know how to fix it. Well, maybe I do. That's c plus mc, and we're solving for c. Solving for c. Oh, that's c. Okay. All right. So here I cannot combine these two because these two are not like terms. Even though I'm tempted to, right? I'm just write 2cm, but that's not doable because you have another variable here, okay, which makes these two unlike terms. All right, so if I can't do that, and I need to isolate one variable on one side, the c variable on one side, I won't be able to do that because I'm going to end up with this term separated from this term every single time. And so that's going to be a problem. So how else can we combine these two c's together? Well, it's by factoring, okay? Even though you cannot combine them because these are not like terms, you can combine them using factoring, okay? What does factoring mean? It means two factors, basically. Essentially, and you can use your own words. Two factors that, when multiplied together, give you back your original expression. Okay. So I know I'm gonna have a parenthesis in there somewhere, and I know that sign is gonna be positive because I want to get this back, right? This sign back. So I know the sign is gonna be positive. What do I need to multiply by? Well, since I need to combine these C's together, that C needs to be out here, okay? And that way you only write it once. All right. And then here, if I multiply C times something, I need to get this. Well, that's 1. If I multiply C times 1, that gives me back my C. If I multiply C times something, I should get MC, right? Well, the only thing I can multiply by is M, and that will give me MC up here. See? So this is correct now, because if I multiply this times this times this, I will get this expression over here. All right. I think I'm done there. So I rewrite everything else, and now I'm here. All right. So now I have isolated my C, my variable C, by factoring now, not by combining like terms. All right. That's important. By factoring. And then from here, I know that I have 2 factors, that's C, and whatever's inside the parentheses. So I don't need to divide by something. Well, I'm going to divide by 1 plus M, and that's going to make it easier, I think. I need to do it to both sides, though. And here, I just rewrite P over 1 plus M equals C, since this goes away. Now I have that C equals P over 1 plus M. And that's your answer. Okay? All right. If you have any questions about that, you need to let me know, okay? And we're done with this class. And you are going to have one of those problems in your assignment, okay? So let's move on to section 8.6. And this is another it's a simple section in that you've already practiced a lot on interpreting word problems, or in other words, translating them into numbers, into algebraic expressions. Equations. An introduction to problem solving. Okay, so that's all it is. We just problem solving, and I will show you a table. Yeah, and this is in section 8.6, page 644. 664. In case you wanted to practice how to translate word problems into expressions, in this case expressions, even though we are going to be using equations. Okay, so just go back here to table 8.5 if you want to practice some more, but I know you did very well on these concepts, and so I'm not going to review any of this except for the word problems that we have on this section. All right, so the book is still also has this section here, this table, where it tells you a strategy of how to solve word problems. But I think it's not complete. I don't think it's complete, and so I don't like it. So I'm going to show you mine, okay? And this works every single time. For any word problem, use the same method, and you should be able to solve any word problem, okay? I'm just going to get a different paper there, and that way it's not all cluttered up. Okay, so solving a word problem. Let's go ahead and start working with example 1. It's going to get a bit wordier. The problems are going to get a bit wordier as we move along, but that's okay. Let's go and start with this one now. 9 subtracted from 8 times a number is 39. Find the number. Okay, so that's a question. That's what you need to find from this expression. So notice what I did. I read it, right? I read it once, but I'm not too sure on what I have to do. So I need to read it again. So that's the first step. that you need to read it. You need to read your Word program, and then if you need to read it once, twice, 3 times, however many times it takes, for you to understand what's going on and how you need to proceed, then go ahead and do it. In this case, once I read it twice, I can see that there are bits of information here that I can use to find the missing number, to find this number. See, because it says 8 times a number times a number times a number. That's this number we're trying to find, okay? And you already know how to express it in an equation or expression. You use variables, okay? The missing values, for missing values, you use variables, okay? In this case, I'm gonna use x. So even if I didn't tell you, use x, and that should do it. The book should tell you which variable you're going to use, okay? Because that's the way you need to type in the answer in Pearson. All right, so I'm gonna go ahead and read this again and underline. If I can underline, that would be nice. So no, you know what? I'm gonna go ahead and do it. So just give me a second here to get a pencil here, because I need to, since I'm telling you my method, I need to go ahead and do the whole thing, do every single step. So, okay, so if I can see that, 9 subtracted from 8, that's useful information, times a number, that's another another bit of information there that I can use, times a number, is 39. That's another useful bit of information, right? Okay, so how do I go about using all this information to find that number, or this number here? Well, this is where algebra comes in handy, because if you can interpret any word problem into an algebraic expression, if you can rewrite it as an algebraic expression, you should be able to solve the problem, okay? You should be able to solve for the missing variable, okay? So that's a hint right there. So I know I'm gonna have an equal sign somewhere in there, because I need to make it into an equation, since I already know how to solve for missing variables, okay? And I don't know what keeps going on here, but so let me see if I can change the brightness of that, because I don't know what it's doing, and I may need to lock this up. All right, let's see how long that lasts. All right, so where was I? Yeah, I was about to rewrite an equation, since I already know that I need an equation. If I can rewrite any word problem in the form of an equation, I should be able to solve for the missing variable, okay? Okay, in this case, 9 subtracted from 8 times a number is 39. It's subtracted from, well, I know that 9 subtracted from 8. 9 subtracted from 8 is this. 9 subtracted from 8 is this, right? Oh, from 8 times a number. See, I missed that information, that piece of information there. 8 times a number. So 8 times a number should go together. 8 times a number. Since I know that I need to use an x for that, for this number here, that's what I write here. 8 times a number. So I'm subtracting 9. 9 subtracted from 8 times a number is, I know that an equal sign needs to go in there because I need an equation, right? Not just an expression. I need an equation to be able to solve for the missing variable. So all of that is 39. So that's what I have now, and this is where this is what it needs. This word problem needs to look like. an equation. If you can do that for every single problem, you should be able to answer all these word problems, even the ones in the ones you take for the school. All right, so let's see. So in this case, you have to solve for x, and then that will be the missing number, okay? And in this case, all you have to do, and I'm just gonna move along quite fast here, and I'm not gonna bother with the steps, since most of the steps are basically the same. They repeat. That's 48. Let me see. Yeah, it's 48. And oops, divided by 8. Divided by 8 here, divided by 8. That's x equals 48. Divided by 8. 6. Because 8 times 5 is 48. So that should be the number there. Okay, the number we're trying to find. All right, and we're done. The only other step would be to solve for, to check your problem, your work. You have to check your work. In other words, to plug in your answer into the original equation. That's all that means. Okay, and like I told you before, in this class, I'm not going to worry about that because it just takes up time. But that's what you need to do. That will be the last step. Okay. Well, I'm going to do it really quick. 6 times 8 is, we said it was 48. Minus 9. Oops, minus 9 equals 39. And 48 minus 9 is 39 equals 39. So yeah, it does check. So that's how you would check your work, and that will be the last step. Okay. I'm not gonna do that again because that takes time, and since I already knew I had the right answer, I didn't worry about that. Okay, I'm gonna skip example 2. I'm gonna skip example 2 and move on to example 3. All right, because I don't think you have a problem that looks like example 2. So, you don't. I already worked them out, and you don't. So I'm just gonna move on to example. No, not that one. No, you don't have any problems like that. So I'm gonna move to example 4. Okay, so again, word problems. If you can set them up as equations, as algebraic equations, you should be able to solve for the missing variable. Okay, so in this case, what I'm gonna do is read. Remember, you read it once, twice, 3 times, however many times it takes for you to be able to tell what it's talking about and what your approach to solving it will be. Okay, so let's go ahead and do that. Brenna Hip Agency charges $125 per week plus 0.2 20 cents per mile to rent a small car. How many miles can you travel for $335? Okay, so that's the question. So that's important. You need to solve. You need to answer the question. How many miles can you travel for $335? That's important. I would underline it. That's important, or at least keep it in mind. And then rental agency charges $125 per week. So I know it charges $125 per week. Okay, so to rent a car, right? However, for every mile, per mile, for every mile, you need to add another, plus means add, addition, adding, 20 cents, 20 more cents per mile. Okay. And then if, so I underline that. Yeah. And then, and then it asks me how many miles can you travel for $235. So that would be the total. That would be how much you pay, right? That would be how much you pay. So I know that this is gonna be on one side. You know how much you pay. Total is always on one side. If you can write the total on one side, that will make your work easier, way easier. Okay, so in this case, I did. And my screen froze. Oh, there it is. All right, so 35, and that's my total. And then for the other side, I need to figure out how this two, when added together, will give me the total, right? Well, I know that 125, you're gonna have to pay 125, no matter what. That's gonna come out of your pocket, 125. But then you're still gonna have to add however many miles you drive, right? However many miles you drive the car, and you need to use a variable, right? Because you don't know how many miles, you don't know how many miles you're gonna drive, right? So that needs to look like an x or some variable, and then per every mile you need to add 20 cents. Okay, so 20 cents plus however many miles plus however many miles plus however many miles you drive. That means the same thing as multiplying, right? Since you're going to be adding them again and again and again, so just multiply times 0.2. Multiply times 0.2. Or you could just rewrite it as 125 plus 0.2x, right? Which means the same thing. And you were probably looking at that already, so because you're used to this, right? All right, and I believe we're done. Well, let me see if I got the first step correct here. And where am I? Oh, that's the second page, next page. Okay, let me see. Did we get it? Yeah, we got it. So that's this right here, okay? And remember, I'm just not writing that 0 to the right of the decimal because we don't need it. We really don't need it. All right, so now I'm ready. So for x, again, I'm just gonna subtract 125 on both sides. You end up with 2.2x over on this side, and on the other, on the other one, and 125. That is, and I'm using my calculator here, so I don't have to take too much time doing this. All right, I believe we're done. I believe that's correct. 135. Yeah, the 135 minus 125. All right, now we're just checking my work. Anyway, divide all that by 0.2. Then you end up with, okay, see, this is why I need to use my calculator. Divided by 0.2. 0.2, that's 1050. 1050. So x equals 1050. And what was x? Well, x was the how many miles the car was driven. So that's it. That's the answer there. Should be the answer. Yeah, it is the answer. So always make sure you answer the question, okay? And in
Pearson, all you have to do is enter the values. I don't think you have to. Well, you actually don't have to enter in the units. Okay, like miles. You don't have to do that. And then yeah. So in this case, this the Pearson is not going to ask you to write all this. No, I believe it's just going to ask you. Well, no, it's just going to ask you for the value. Okay. So yeah, even though this, you would answer the question this way, yes, your car can travel 1,050 miles per for $335, right? Pearson's not gonna ask you to write the whole thing. Okay. Anyway, we're done with that. So I believe that was straightforward. I think. This here are gonna get a little bit trickier, but still the concept is still the same. If you can write them as an equation, rewrite them as an equation, you should be able to solve for the missing variable. Okay, so let's go ahead and move on to example 5 and see if we can translate into an equation. If we can, we are one step ahead. We should be one step ahead. Okay, so let me see. What's the procedure? Well, read. Rectangular soccer field is twice as long as it is wide if the perimeter of a soccer field is 300 yards. What are the field's dimensions? So I know that it's talking about perimeters, so that's what dimensions means. Talking about the perimeter of the soccer field is 300 yards, and a rectangular soccer field is twice as long as it is wide. That's very important. So I underline it. Well, let's keep it in mind. And then from here, another good tip would be to draw any anything you have, anything that helps you answer the question. In this case, I'm gonna draw a field, right? Draw a field there. If this helps me answer the question, okay, so let's see what's happening. Okay, so I know the perimeter is, the whole thing is 300 yards, okay. The rectangular soccer field is twice as long as it is wide. Okay, so if this is W, this side here, then the length would be what? Length equals let's see. W is W. Yeah, let's leave it. Well, no, W is X. Because that's the missing variable. Okay. And then length. Let's say that is well, it is twice as much as the length. Okay. So I'm not using L or W for the missing variable. Okay. So I'm just using it here so you can see that the width is X, because we don't know what the width is. So it doesn't tell us. It does tell us that length is equal to the width, which is X, and it's twice as long as the width. In other words, multiplied times X, 2 times X. All right, so this is the important information right here. Now, I didn't mean to mislead you here with this L and this W, which we're not going to use, okay? But the only information we're going to use is this X and this 2X, okay? And then from there, I know that if I add up all the sides, I'm going to get 300, right? So if I add all those sides, I'm going to get 300. So 300 goes on one side, see? So this is good because that's the total, and I was able to put it on one side. Remember I told you to put the total on one side. If you can do that, you're halfway there, halfway to answer the question. So in this case, on this left side, we need to add all these sides. We could do it one at a time. Well, let's go ahead and do that one at a time. X plus 2x plus this side is also x, right? Because it's the same as this, right? So it's x, so it's x. This one is also 2x long, okay? So I need to add it here too. Notice how you have two of each, right? So we could have done, what we could have done is write 2 times x, right? Say 2x. When you combine this together, you end up with this. We could have also written 2 plus 2 times 2x, or you could just combine them here at this step, and that will make this 4x instead of 2 times 2x, right? So we could have gone from here to here, okay, in one single step, if that's what you wanted to do, okay. You didn't have to, but we could have. Just letting you know that could be a shortcut there. And then equals 300. Everything equals 300, and now we're here. 2x plus 4x equals 300. All right. Do we have like terms? Yes. In this case, we do. So we combine them together. That's equals 300. And then divide both sides by 6. Both sides by 6 equals 300. That's 300 divided by 6 is 50. Yeah. All right. So the answer, the missing variable is 50. However, we are not done. We're not done yet, because the question is what is the field? What are the field's dimensions? Okay, what are the field's dimensions? Well, what does the field look like? It looks like this. So the field dimensions are, if we substitute 50 into the dimensions here, you end up with 50 here, 100 here, because 50 times 2 is 100, then 50 here, and 100 here. Those would be the dimensions here of the field, okay? And in Pearson, it's gonna ask you, it's gonna give you a box at a time, so you don't have to write all of this, okay? But still, you would just write one single value in Pearson, okay? And that's it. We are done. And yeah, that's the right answer. X equals 50, okay? And let's move on to the next example there. And again, let's go ahead and if we can let me move this around here. There. If we can rewrite this in algebraic expression, or make this word problem into an equation, you should be able to answer the question. Okay? So in a triangle, the measure of the first angle is twice the number of a second angle. The measure of the third angle is 20 degrees less than the second angle. What is the measure of each angle? Well, that is what we're trying to figure out. What is the measure of each angle? Okay, of each angle. That's important. I know that's important. Therefore, the measure of the first angle. So this information is going to be important. Okay, all of this information, because the first angle is twice the measure of the second angle. Okay, so that's important too. And then the measure of the third angle. Measure of the third angle is 20 degrees less than the second one. Okay, so that's important too. So I would underline it or keep in mind. Okay, All right, now I'm ready to figure out what the equation looks like. For that, again, if at this step you can make a drawing of whatever the situation is. It doesn't just have to be figures. Whatever the situation is, if you can make a drawing, and it should make the finding the equation, equivalent equation of this easier. Okay, so in this case, let me go back here to the first angle. First angle is twice. Okay, so let's say that this is the first angle here. First angle, second angle, third. Okay. And then the first angle is twice the measure of the second angle. Okay, so that equals, so the first angle is twice the second angle. Okay, and then however, we don't know what the second angle is. So let me see if I can figure that out here. So the third angle is 20 degrees less than the second angle. Well, again, no, it doesn't tell me what the second angle is. So I know that I can substitute the second angle for x, see? And again, I don't mean to confuse you with these 2 and 3. Those are just the angles, okay? These are the missing variables. This is what we're going to be using, okay? And then from here, I go back over here and see that my first angle is twice the measure of the second one. I know that the second one is going to be x. So my first one is going to be 2 times x. And then for the third one is going to be 20 degrees less than the second angle. This doesn't translate into 20 minus x, okay? This is not 20 minus x. Not in this case, no. In this case, just if you think about it, as you read it, 20 less than the second angle means x minus 20. You see, because if you subtract 20 from x, that means 20 degrees less than x. Okay, so this would be wrong. 20 minus x would be wrong. Okay, so again, go back to that table that I showed you a few minutes ago and practice this. If you can remember, just go ahead and practice it a few more times and you should be okay. All right, so now I have all my angles. Okay. Well, how do I need to solve this? Oh, by the way, it's talking about these angles. My goodness, that's an angle. This is another angle. Oh, I didn't mean to do that. Well, in this case, all these angles are the same by using that thingy right there. But I'm not doing that. These are not the same. They shouldn't be the same. I don't know if they're the same. See, that's the thing. Anyway, but what I meant was, what they meant by angles, they meant these inside angles here. Okay. So what do I know? See, this in this problem here, they are expecting you to know that the measure of the inside angles of any triangle, okay, equals 180. Okay, equals 180. So that's common knowledge in high school. Should be. They teach you that. So that's one of the rules. And this is every single time for any triangle. It doesn't make a difference what shape it is in. The measure of the inside angles is 180. Okay. All right. I already knew that, so I know that that's gonna be on one side by itself. And my okay, there it is. And then the other side, just add up the other angles. The measures they gave you. X minus 20. X minus 20 is angle 3. Angle 2 is x plus x. Angle 1 is 2x. Yeah. So if I add all of this up, I should get 180. So that's what I'm doing here. I'm adding them up. Okay, what does that look like? Well, in this case, I do have a parenthesis here, right? Sure. Because that's just grouping this whole angle, okay? That's okay. And in this case, though, I can get rid of it because I'm not subtracting, okay? So this is still going to be positive even if I get rid of the parentheses, okay? So once I get rid of the parentheses, they're going to look like this. The whole thing is going to look like this, okay? All right, now I'm here. I need to combine like terms, okay? So I do have my x's. Those are like terms, okay? So I just add them up. 2 plus 1 plus 1. That's 4x. Minus 20 because I didn't do any to the 20, so I just rewrite it. That's 4x minus 20 equals 180. All right, and from here, yeah, just a matter of using the addition and multiplication properties of equality, and you should be able to solve for x. So that's what I'm doing here. 200 divided by 4 is 50. All right, and that should be the answer for this problem. So let me just check if we did everything correctly by checking our work here on that book. And yes, we did everything correctly. So x equals 50. All right. Now remember that even though you solve for x, this is not your answer. No. You still have to go back and answer your question, okay? What were they asking? They were asking what is the measure of each angle, okay? So an important part of solving a work problem is not just doing the work, it's answering the question. And the question was, what is the measure of each angle, okay? So if x equals 50 and angle 3 is, well, let's go ahead and start with 1. Angle 1 is 2 times x, which is 50. That should be angle 1. And 1 equals 2 times 50, angle 2. And let's do this just to tell them apart from the numbers. These are angles. And I'm just doing that. You don't have to do that, but because all you have to do in Pearson is enter these answers here. You don't have to do any of this, okay? So just to tell them apart, I'm doing this. And then angle 2 is x, which is 50. And then angle 3 is 50 minus 20. All right. And then just multiply. Go ahead and simplify that. All these equations, go ahead and simplify them, and you end up with angle 1 being 100, angle 2 being 50, angle 3 being 50 minus 20, that's 30. All right, so if we were to check them, 100 goes here, 50 goes here, and 30 goes here. If we were to check them, then we will have to add them up, and these values will have to add up to 180, and they do. 150, 180, because that's the rule. That's for any triangle, the inside angles add up to 180. All right, so we got it. So the answer should be this. So that's what precisely what you need to enter in the assignments, just the values there. All right, not any of this. All right, and we're done with that. I'm gonna go ahead and move on to the next one here, next example. And this is gonna be a bit harder, the hardest one, I think. Well, not the hardest one because we still have another one there at the end. So, or is it this one? No, I think we still have one more. No, that should be it. Okay, that's good. So let's see. Example 7. Your local computer store is having a sale. After a 30% price reduction, you purchase a new computer for $980. What was the computer's price before the reduction? Okay, so what was the computer's price? Computer's price before the reduction. Okay, because that matters. So that's what I will underline. Okay. Let me go ahead and read it again. Your computer store is having a sale. Okay, so it's having a sale after 30% price reduction. That's important. You purchase a new computer for 180. Purchase a new computer for 980. Okay, so all those are valuable pieces of information. What do I do with those? It's a bit more difficult to tell what you need to do here, because here this 30% is a price reduction. It's only a price reduction. You still have to find out what the price before the reduction was. Okay, so so you're not trying to find just 1%. So the percentage of it, the percentage of something. You're trying to find the price before the reduction. So that's gonna make it a bit trickier. However, I know that 980 is a total of something. So I know that 980 goes on one side of the equation, and then the tricky part is going to be figuring out what the other side is going to look like. So after 30% price reduction, okay, so 30% of what? 30% of what? 30%. And remember that 30% times something is going to give you some value, right? So 30% of what? You purchase 30% of well, if we go back to the question, what do we need to find? What are we trying to find? More than likely, the question is going to be your X, your missing variable. Okay, what was the computer's price before the reduction? Okay, computer's price before the reduction. So let's say a computer price equals X. Oops, X before the reduction, right? Before the reduction, because this is the price for the new computer. Okay, so the price before the reduction, let's say it's X. Okay, what can we do with that? How can we use it here to find the price of the new computer? Well, I know that that's going to include the percent discount, right? So I know that I'm going to get a percent discount of the original price. Okay, yeah, the original price, basically the price before. And if I can find that and subtract it, if I can find the percent reduction and subtract it from the original price, so right, subtract it from the original price, and that's going to look like this. It's not the other way around. Okay, so remember that it's not this minus X. No, that would be wrong. That means X, in other words, the original price, or the price before you subtracted the discount. See, before you subtracted the discount is this, right? So we're on the right track. So I need to subtract the discounts from the original price to get the value of the new computer, okay? To get how much you pay for the new computer. Well, how do I figure that out? I know that it's 30% of something, right? 30% of what? Well, of the original price, of course. Yeah, 30% of the original price. How do you get 30% of anything? Well, just multiply it, right? In this case, you multiply 30% times x, right? All right, and I believe we're done, because if we take away the 30% reduction, 30% reduction, which is this. If we take it away from the original price, we get the price of the new computer. So I think we're done. So I'm just gonna rewrite that over here, and I'm gonna write this percent. I'm gonna convert it into decimal right away by moving it to the left twice or dividing by 100. That's 0.3x equals 980. All right, and now we're here. Okay. All right, so all we have to do here now is combine like terms if we need to, and in this case we can. So the only thing we have to do is subtract 1 minus 0.3. Let's see, would that be 0.7? 0.7x. Hope I'm not mistaken. Equals 980. And I'm still gonna use the calculator anyway, so I'll go ahead and check that. 1 minus 0.3 equals 0.7, and then from here just divide both sides by 0.7, and we get 980 divided by 0.7. And yeah, you're gonna have to do this by hand, but it's only one problem, so it shouldn't take you that long. And in this case, it is 1,400. Okay. So from here, now I have the price, the original price of the computer, which is this price before the discount. See, price before the discount is this. Well, no, and then once you subtract the discount, you get this, right? So how do we check it? Well, think about it. If the price before that was that, and we needed to subtract 30% of this, 30% of that, 30% of that from the original price, 30% of this, and this the original price, I just substitute the values in here. See, that's 30%. 30% times 1400, and that should give me 980. Okay, so I'm just gonna go ahead and use my calculator here. I have 1400, and right there, 1400 minus. So I'm just plugging into the calculator. Minus 0.3 times 1400. That should give me 980. See, that is. So that's correct. We got the right answer. Should have. And yeah, we did. From what the book tells us, the answer is 1400. Okay, so did we answer the question? If you're writing it down, then yeah, you will have to answer the question this way. You wouldn't just write 1400. You will have to write a computer's price before the reduction was 1400. Okay, so that's the way you would answer the question, right? In Pearson, though, all you have to do is enter this price here. Yeah. All right, and we're done. that's the end of the class. And if you have any questions, make sure you ask them on the forum Thursday from 2 to 3. All right. You don't have to, but I'll be there. Anyway, bye for now.